Hello everyone, Rahul Kekil again. Thank you very much for watching my previous videos and thank you very much for liking and reading your comments. Very grateful. Hello all my guys. Today, I'm going to create a video on considering five very important principles for making IT applications very efficient. But believe me, based on my experience of life, 90% of the fields, all the different fields of life, whether it is IT, whether it is any other domains about transport or food or anything, any domain, if you will discuss the basic principles to make our business or product more efficient or deliver more quality, those principles remain same. So same five principle can be applied in any domain, but what differs is how to implement those five principles in the different domains. Suppose if I have to implement particular principle in IT, that principle can be implemented through the tools and process relevant to IT. But the same principle when I have to implement in transport industry to make my services more productive or delivering more quality, so same principle will be delivered through different tools and processes relevant to that domain. That's it. Otherwise, the principle remains same. Okay. Okay, guys. So I will discuss five most important principles when we are designing IT applications. What are those five very important principles we should take care, and how we are taking or following those five principles in our daily life also. Fine. So the five principles first I would like to point out. First one is how fault tolerant the IT application is. Second thing, so according to the second point, how much capacity an IT application can vary in its own limits. Means suppose if the capacity demand is more, is it able to expand to the to meet that capacity level or computing capacity, or if maybe not much computation power is needed. So maybe how it can scale down or scale in its resources. So that is the second point. Third thing, how much secure that application is, and third is how much cost optimized that application is, and fifth principle is how easy or how attractive the user interface of the application is. Fine. So I will discuss these five principles one by one with you to design efficient IT application. And as I mentioned, I will be giving at least one example from our daily life, that how we are taking or how we are following this principles. Okay, here I go. So guys, here I go with my first principle for designing the efficient IT application is the fault tolerance, or maybe the resilient application is the more appropriate word. So first I would like to discuss what is tightly coupled architecture and how we can bring resilience in that architecture. So what is tightly coupled? Suppose if there is a suppose website. Okay, so if we launch a website, what are all servers we need? We need an application server where the application code of the website will be residing. Then we need a web server where internet request from the website user will hit, and then it will direct to the application, and then it will go to the database. So we need at least three servers: application server, web server, and third is the database server. So now what is the tightly coupled architecture? Is suppose if we are installing all these three servers on the same physical machine, or maybe a big server which is hosting all these three things. So that is called tightly coupled architecture. So now what is the downside of this architecture is, suppose if there is any issue with that hardware, so all three servers we cannot access web server also, application server also, and the database server also, right? So that is the disadvantage of the tightly coupled architectures. And now I will discuss that how resilient design can overcome this problem. Okay, so here I go with the description of resilient architecture. Okay. Hi guys, so I would like to discuss three different methods to make our IT applications resilient. So first one is to design multi-tier IT application. Second is fault tolerant on the basis of DNS routing policies, and third is decoupling of the application. So I'll discuss all three of them one by one. So first one, is the multi-tier architecture, multi-tier application architecture. Okay. So, guys, basic concept of multi-tier architecture is, as I discussed in tightly coupled architecture, all these three different servers, maybe web server, application server, database server, are on the same physical server. But here in the multi-tier architecture, what we do is we deploy or host all these three different parts on three different physical servers. Or if we are using virtualization, so there may be different boundaries specified for all those three things, so that will be a separate container in itself. So those are isolated with each other. So if at all, if a web server is down, still you have access to the application code and you can use that internally, right? Or even if application server and web server are down, still database server is accessible and you can write at least queries to get the data, right? So this is the first way to introduce resilience in our design. Okay. Now, second thing is fault tolerant design on the basis of DNS routing. So, what this concept is, right? So, just for example, suppose we are trying to build a web application where we may expect maybe some 5 million users every day, or maybe some maybe at least 50,000 user per minute or something. Just one example. So what happened? Uh, we may host our applications by on the cluster of servers, right? So there may be different web servers which are in different availability zone and which can connect to the different application server on the basis of availability of those particular server which are existing in the same availability zone. So what happens? Suppose when we design our web application, so the websites are accessed through DNS. So I may upload a separate video how does DNS work and what is DNS concept. But I just want to explain this architecture principle also, that suppose when web server, first of all it goes through the application load balancer. So what happens when web server gets the request? So first the request goes to the application load balancer, right? So and then it checks that which particular application has how many active user or concurrent user at that particular time, and then the load balancer decide that this particular request should go to which application server, and then internally it will connect to the database server to give output, or maybe execute the user's request. So suppose when web server is trying to connect to an application server, and because of some reason if that particular application server is down, so then the load balancer will decide on the fly that now if this server is down, so this request should be routed to which particular application server. And same goes with the web server. So when the internet gateway is getting a request for the web server, and suppose if a web server is down because of some reason, so that time the DNS routing fault tolerant policy must on the fly, it has to make that decision that if according to the health check. So all this load balancer can perform the health check. So during the health check, if a load balancer find that a particular web server is down because of some reason, so on the fly that load balancer, according to the DNS routing policy, that particular web request or website request need to route to the different web server which is running perfectly fine. So that is another way of bringing resilience in our application. Okay. Okay, so now I would like to discuss the third way to introduce resilience, that is called decoupling of the application code. So what is decoupling? So maybe in our childhood, in our mathematics, we know what is factorization, right? So suppose there is a number, suppose maybe 42 or some random number I want to discuss. So when we calculate its factors, so its factors are those smaller number compared to that number which I'm discussing, and which can divide that number. So all the crux is the factorization is breaking a particular a big unit into smaller units. So that is called factorization, right? So that's how, if our application is very big, so according to the functionality of application, we can build several application code base, maybe one code base can serve one, at least one full functionality, right? And then definitely see all this a small part of that bigger application, now they need to communicate with each other, right? Then only the final outcome can be expected. So when the message needs to be passed from one application code base to the another one, so there are many messaging tools like MQ message, SQS. So in that way, what happened, even when we factorize our application code also, so if there is any issue with a particular a small factor of the application code, still the other application code base is still running, right? So that is another way of bringing resilience into our IT application design. I hope I'm clear with the first principle of designing or bringing resilience in our IT applications. So now I want to discuss that how we are already taking care, or maybe we are knowingly and unknowingly doing in our daily life. Okay, so here I go with just two small examples. So the first one I would like to discuss is, as we all know that there are two types of tire available, with tube and tubeless. So, see, no hard feeling. If somebody wants to go with the tire with tube, that's perfectly fine. It can be his personal choice. But the tubeless tires bring a little bit resilience, and how it is, even if it is punctured, the vehicle may still travel to 70, 80 kilometers, and then you can find a shop to fix that. So that is one kind of resilience which we are already taking care in our daily life, right? Second one, if suppose if an area is very earthquake prone, so the construction of the houses will be accordingly, that it will be light wood or something. So again, the resilience thought is not something which is alien, and we are trying to learn only in IT application. It's not like that. We are already doing it in our daily life, but only thing is that the implementation of the idea which can bring resilience in that particular field of life, the implementation may be different, but the concept or the principle is the same. Okay, fine. Thank you. Hi guys, just before I move to the second architecture principle, I just would like to discuss one more example just right in my mind, because in our resilience principle I discussed the third point, that how we can factorize our application code, and then it can communicate with each other through a messaging system. So just one example strike my mind, that see our own body, right? So all these individual body parts are made to serve one particular functionality or purpose, but then when it has to work in conjunction, the message is passed through our brain, right? So if our left hand has to do something with the right hand, the message is passed through the our brain, and then these different body parts work as a unit, right? And definitely, if maybe my one of my hand is hurt because of some reason, so I can still do some work with my other hand. So just one example, right? So it may be really more difficult for me to understand or explain my own body functionality compared to the IT application, but just one example strike my mind. That's it. Okay. Hi guys. So the second principle which I would like to discuss for the efficient IT application is ensuring uh, the capacity based on need. Fine. So let us first discuss example of daily life. Then it will be really easy to discuss and understand. So suppose we have a folding dining table, right, or extendable dining table, right? So maybe folding dining table, when we don't need, we can just fold it and keep it, so it's not at all like occupying any place, right, or space, right? And then if we have a extendable dining table, so maybe it's four-seater, but on the based on need, we can extend it to eight-seater, six-seater, so whatever its maximum capacity is, right? So again, we are thinking about making the capacity available of some particular item based on need, right? So, and another example, if we have a picnic table, so again, that can be folded picnic table. If we don't need, we can fold it and keep it. But if we need, even on the based on need, it can be made a two-seater, four-seater, six-seater, or eight-seater based on its maximum capacity. So that is the crux, that we are already thinking in that line, and that is part of our daily life. Okay, so now let us discuss that how to implement this in IT application, and a very interesting use case, or maybe scenario, to understand that how this ensuring capacity of IT application was taking place before the cloud technologies, and how this has become very efficient and still evolving and going towards the excellence after the introduction of cloud technologies. Okay, so let us try to understand now the same principle of ensuring capacity based on need in IT application. Okay, so here I go. Okay, guys, now let us try to understand a use case for ensuring the capacity, meeting the capacity need based on requirement for the IT application. So let us see, let us discover an example for an e-commerce website. Suppose every day they're expecting 5,000 users, suppose, on their website. But if they are in their promotional event, maybe if they are offering some 70-80% discount, so now this time uh, they may expect 5 lakh people in a single day. So now it has the website hit has gone by 100 times, right? So now how to ensure capacity for meeting this requirement, maybe just for 3 days, or well, this is just one use case. So the duration may differ, but this is just one example. So now let us try to understand that how this ensuring capacity was done before cloud technologies, and how this cloud technology has made it very simple, very cost efficient, and uh, just go, even this technology is still evolving and taking it towards the excellence. So let's try to understand that how this capacity demand might have made when there was no cloud technology. So in this case, suppose a company was using maybe one server for 5,000 people. So maybe just for 3 days now they need 100 servers. No? And after 3 days, what will happen to those 99 spare servers after 3 days? May not be needed, right? So so a big capital is blocked, and now even top of that, those 99 hardware of such a very high configuration is not in use, regular use. Maybe sometime 6 months later, if they are again coming with a promotional event, then only they can use those additional servers. So now, so here the importance of cloud technologies come into picture, right? So if the website is hosted on cloud, if the web server, application server is hosted on the cloud, so what will happen? So we need to indicate our cloud provider that for this 3 days we need this much, this many capacity. So in place of one web server, we are expecting 100 web server for just 3 days. So then that cloud provider may charge you just for 3 days on the basis of utilization. Then again, there are different costing and billing methodology. So that I may upload some separate videos on cloud technologies, definitely. So just I wanted to give you one use case that how the capacity can be made available based on need, and we discussed how it was done before cloud and how cloud technologies has made it very cost efficient and easy for companies to manage that. Fine. So now there are few terms called scale out, scale in, scale up, and scale down. So just we need to understand. And again, I will be uploading very detailed videos on this in my cloud playlist. So here I would like to go back to our daily life example, what we discuss of extendable dining table or a picnic table. So when we are actually expanding the table on based on need, so that is we are expanding on maybe the physical components are getting added through that expansion. So that is called scale out, right? So suppose if there was one physical web server was used for daily purpose, but this promotional event, if 99 additional physical servers are added just to meet demand for those 3 days, so that is called scale out. And once that much capacity is not needed, then again those that many number of physical components will be removed from the infrastructure for that particular company. So that is called scale in. But here we need to understand what is scale up and scale down. So scale up is something we can discuss, though I have not seen such a maybe drinking glass which we can just pull it to make it a bigger size. So the same physical component, if it is increasing its own capacity without adding any other physical component, that is called scale up. Okay, so there are few things which can be done through scale up, and then when if we are again bringing it to maybe its original size, so that is scale down. Yes, so we discuss scale out, scale in, and scale up and scale down. So we need to understand. which components of software we can use scale out scaling, and where we need to use scale up and scale down. So that is another principle. Okay. So guys, just before going to the third, best practice for architecture, I would just like to discuss that how to implement scale out and scale in policy, and that too linked with our daily life. So, as we discuss, maybe a picnic table. So, on what basis we will, open it for just two people, or when we will make it four people? It's very easy. When we are on, outing with two people, two-seater, expanding it to be two-seater is enough. But if there are four people, we'll make it four-seater. Very simple. So there is a trigger, right? There is a criteria, right? So same way, if for IT application we need to scale out, so what we need to do? We need to define some criteria that after once this criteria is met, and now even if the demand is going further, now we need to implement our scale out, and when again those criteria or whatever we decided according to our logic is you know, uh, reducing in number, so again we need to go for scaling. Definitely same principle as our daily life. So how to implement an IT is very simple. There are many tools which can keep monitoring the requirement or utilization of the physical computing you know, parts. Like suppose CPU, if it is utilized 80% of for a particular physical server, so that time this is just an example that we can set a criteria that once the CPU utilization uh, just crossing 80%, then we need to trigger an event, and then our scale out policy will start adding the new physical components to expand, or maybe addition of new computation power to meet that requirement. Very simple. And when again the CPU utilization is coming down from 80% to 70% or 60%, then again we will go for our scaling policy implementation. That's it. This is just one example. So based similarly, we can set multiple criteria to scale out and scale in. Clear? Okay. Hi guys, the third most important principle of efficient IT application design is security. In my opinion, security is always paramount when it comes to daily life or IT application or any field of life. So I have a separate video on cyber security, how to implement it and its importance, which talks about how to make our IT application secure. So I will request you to please watch that video. And as you know, I just mentioned this topic here, so I would like to give just one daily life example. Though I have explained everything in cybersecurity, but as I'm pointing out the third principle here. So in our daily life also, we may be a very good driver. Maybe suppose if you're driving a car, but still we must use the seat belt, right? So it's always good practice to put some belt and braces around all our activities in every field of our life, and IT is none other than that. Fine. So please, I'm requesting you to please watch my a detailed video on cyber security and how to implement it. Okay, this is the third principle. Thank you. Hi all. The fourth most important architecture principle of IT application is cost optimize IT application. But as per our daily life, first I want to discuss one example from our daily life, and then we'll come to how to implement it in IT application. So, the same example of a picnic table or a dining table. So somebody may opt for a very costly table, or very very costly dining table. Maybe some part of it may be of gold, but definitely no hard feeling or no negative remarks on somebody's personal choice. Definitely he can go for it, but somebody else can think that if he can get picnic table or a dining table manufactured or built by a material which is not harmful for the health and suffice the purpose, so that he can go for it. And that may be cheaper if that suffice the purpose of the same function. But it totally depends on the individual choice. But that's just to give one example from the daily life. So there also we are considering optimized option for all our buying or whatever we choose. We definitely consider cost optimized product, or whenever we are making choice. So fine. So same way how we can implement an IT application. So guys, whenever we are designing any system, whether it's IT or whatever, in any domain also, so all this principle must be considered when deciding for all the aspect of that particular application or any product which we are manufacturing. So all this five different principles which we are discussing should be considered while designing every part of IT application, and all the components must be validated or at least reviewed under against these principles, whether we are following that or not. So I would like to just give one example. So I would like to discuss just one example how to we can optimize our cost, and this is the same what I discussed in making our solution scalable, or ensuring the computation power or capacity available based on needs. So on the same example, if e-commerce application expects 5,000 users per day and able to cope up with one server, and they are able to serve all those 5,000 customers with one server, but during some promotional event, if they think for 3 days a promotional event for 75% discount, and they may get hit from 5 lakh users, so that time they need 100 server, right? So how to arrange this 99 additional servers again? This is one parameter called provisioning of infrastructure, that also should be considered or reviewed against all those five principles. So here again there is a choice for with the organization. They can buy all 99 servers and keep spare, and whenever they want they can use it. But the another option I told you, that the cloud provider can arrange those 199 additional server for only 3 days cost. So again, so this architecture principle, or the way architect think or organization think, that will lead to architectural change for IT application from organization to organization. So this is just one example how we can think about making our IT application more cost optimized, right? Fine. I think I hope I'm clear. Fine. So guys, here I go for the discussion of the fifth and last very important architecture principle, and that is attractive user interface and ease of navigation, or ease of understanding by a user who is going to use our application, or if the application is built for some other purpose, any of the user for that application should be understand and should be attractive, and ease of navigation for that user also. So I'll just give you an example from the daily life, suppose, or maybe from other domain. If somebody is constructing a restaurant, so what he needs to take care, first is the beautiful elevation of the building. Maybe elevation is a civil engineering concept, I don't want to go for the detail, but the beauty of when somebody is just seeing the restaurant, so what impression he gets from that elevation of the building, and how easy the entrance is. If suppose if somebody is allowing all the parking in front of the gate, so there may be a hassle while entering into the hotel or restaurant, and then maybe how comfortable or easy the sitting arrangement are, and how uh, easy to choose from the menu, and how quickly it serves. So all those things comes under all comfortable of the user, right? So same way how to implement in IT, that's it. Okay. So suppose if somebody is designing a web application, so again the UI, if he has to create attractive UI, he can use different tools like CSS and JavaScript for the front end, and then how beautiful and ease of navigation or understanding he builds with the user. That totally depends on your UI design, and if there is any other application, so there may be relevant tools should be used to make the UI attractive and very easy to understand for the user. So that's it. So these five principles, if you will take care, I'm 100% sure that the IT application is going to be very efficient. So first one was considering a resilient approach for designing IT applications. Second one was ensuring the computing capacity available based on need. Third one was security. Fourth one was Fourth one was cost optimized application, and fifth one was how attractive and easy user interface for the user. That's it. All the very best. Keep track of this five principle not only in IT application, in any domain. Wherever you want to make your work more efficient and provide more quality, just consider this five aspect when building anything, IT application or any product of any other domain. All the best. Have a nice day. Okay, guys, on the final note, I would like to say that these five principles are like these five fingers of our palm, but they need to work, together, very closely and integrated with each other to get our work done efficiently and to deliver more quality in any domain as per, based on my experience. But definitely, this video was based for, or I created this video for IT application. Okay, thank you very much. Best of luck for the development of the planet. Okay, bye.